We're at the Connected Lighting Testbed, which is a laboratory facility for research and testing of luminaires connected to IT infrastructure type of environments, networks. Wi-Fi, could be cellular networks, it could be Ethernet networks, but they generally are lighting fixtures that communicate data back and forth for control and reporting purposes. This is a ceiling that we can raise or lower to a height appropriate for particular testing that we're doing here. It can go up to close to 20 feet or pretty much close to the ground level. We have the ability to measure the power going to the luminaires, the AC power, so that capability is built into this adjustable ceiling. This black pair of boxes in the center is the data capture for our AC power measurement for all of the circuits in our two variable height ceilings in the high bay space. We have Ethernet cabling brought to both of these ceilings that allows us to do wired networking to the luminaires, and for the newer technology of power over Ethernet allows us to provide the DC power to those specialty luminaires that we also have several of installed in the ceiling at the moment. We also have street lights that were connected on the walls, and this allows us to communicate with them, control them, turn them on and off, read information back for them, perhaps how much energy they're consuming at this point in time, if they see any motion below them, things of that nature.
We felt we needed to prioritize some features or functionalities that would be key to the development and eventually the adoption of connected lighting systems. So this led to the identification of focus areas for connected lighting. First and foremost, we are the Department of Energy, and one of the types of data that these systems can produce is energy data, some form of estimate of the luminaire or lighting system's own energy consumption. Having access to this data enables lighting really for the first time to become a resource that can be managed from data. So we think it could be the most powerful tool to enable people to really optimize their lighting energy consumption. We think there's many other uses for energy data too.
Our February 2017 report on the energy reporting capabilities of power over Ethernet lighting systems identified a number of knowledge gaps and areas for potential future study. One area for exploration was energy losses in cables in PoE lighting systems. Fortunately, a standard was published shortly after publication of our report that provides guidance on minimizing energy losses in PoE systems. We decided to do some testing to develop some data that we can then share with the public. We're looking at a variety of different cables, 12 different models spanning a variety of manufacturers and different designs and wire gauges to see how they hold up. To vet the accuracy of a test apparatus that we've put together, we started looking at connected outlets to see how these various products perform in terms of energy reporting accuracy. One area of study in connected streetlight systems is the energy reporting accuracy of these connected streetlight systems. A first technology that we're investigating is connected streetlight control nodes and looking at their accuracy of energy reporting.
Interoperability is a new topic in terms of specifying. So educating people on how to specify interoperability is another important activity. And as manufacturers start to make claims about interoperability, then there's the objective of understanding and characterizing how well they're meeting those claims. So we're right now more thinking about interoperability from a user perspective. And so if I'm a building owner or a city right now and I want to install connected lighting products and systems from multiple manufacturers that produce data, and I want to be able to enable them to share that data and make use of data produced by another system, the answer is today through application programming interfaces. It's a guidebook that instructs someone how to talk to or communicate with a system. Many connected lighting systems have application programming interfaces, and they're at various states of maturity and use. And that suggests one focus for us in the realm of interoperability is to take a look at those application programming interfaces that are being provided by different manufacturers and see if we might characterize them. What do they enable? What do they not enable? How well do they work? And how might using them be easier? Another focus area that came to us from stakeholders is cybersecurity. Technology and infrastructure that traditionally either has not been connected, at least with communication systems, or if it was connected, it was isolated in a silo to all of a sudden being interconnected with other building systems and maybe eventually the World Wide Web, which then exposes these systems to cybersecurity issues that can create risk and havoc and lack of comfort of using the connected technology. This is a mix of both hardware and software that might monitor a network or sit at interfaces in the network and look for either known vulnerabilities or, over time, activity or occurrences that deviate from normal activity or occurrences, right? And might be indications of something malicious going on.
We have engaged with several partners to help develop this cybersecurity testing capability. One such partner is Underwriters Laboratories, UL, which has engaged in their own certification process, and we have been in communication with them to create the same kind of testing capability here at the Connected Lighting Testbed. We are also engaged in discussions with cybersecurity specialists to get some of their special recipes and testing processes in place here in the lab as well.